Okay. So my question, this was what, 2.13, that's the question. Now let's get to the question 2.14. We are still on November 2017, question 2. Let's do now 2.14. Let me erase this one and do 2.14. Right, 2.14. What is very important about this question? They say now, if the force F, still that 8 kg block, sorry for 30 degrees. P. What they say now is they say if force F is removed, if this force is removed, is taken out, we all know this 8 kg block is going to fall in this direction. We all know that. If we take out this F, suppose you were pulling something, a box in an inclined plane, then you decided to release that box, will move in that direction because there is a force of gravity that attracts this 80 kg down. So they say now the block accelerates down the plane and the kinetic friction force is still 20. So what is very important, the kinetic friction force is still the same, 20,37 Newton. Right, calculate the magnitude of the acceleration of a block. In the previous question 2.13, we said acceleration now, velocity was constant when the object was in an inclined plane. So we said when the velocity is constant, it means when the force was exerting on the 8 kg block, my acceleration was 8 kg in 2.13. But now in 2.14 they said you have taken the force out, then the block moves down. So we remember the acceleration is not constant now. It was constant when the force was applied on the 8 kg block, when the block was moving upwards. It was, read the statement, your acceleration was constant. I mean your velocity was constant, your acceleration was 0. But now you remove that force, it moves down, it accelerates. Your acceleration in this question is no longer equal to 0. Now what is very important, how many forces are acting when this thing, there are two forces. The force of gravity is acting down and the friction force is acting in the opposite direction. So there are two forces that are acting now. It's the force of gravity. We call it Fg parallel. We remember in an inclined plane, when everything is in an inclined plane, where is the force of Fg? We said this is one, this is Fg perpendicular. Fg perpendicular, which is equal to mg cos theta. This one is Fg parallel. This one is parallel to that one. We call this one Fg parallel, which is equal to mg sine theta, which is the vertical, which is the composite vertical mg sine theta. We call Fg parallel. So two forces acting is the Fg parallel, force Fg parallel minus the friction is mass times acceleration, minus the friction force is the mass times acceleration. This is Fg parallel. So what is my Fg parallel? As I tried to that is Fg parallel will be mg sine theta, but the Fg perpendicular, which is equal to normal, is mg cos theta, which is equal to normal. And normal is equal to Fg perpendicular. Right, I'm not there, I was just to explain how to get all these things. My Fg parallel will be mg sine of theta minus the friction. So mg sine theta minus the friction force. What is my friction? Is 20. It's 20,37. What is my mass of the block? Is 8 acceleration. Your acceleration, according to the statement 2.14, my acceleration is not equal to 0. It was equal to 0 in the previous example 2.13, where while the force was being applied upwards. Right, what is my mass? Mass is my 8 times, what's my G? 9,8. Sin 30, I think it's half, 0.5. Minus 20,37 is equal to 8 times acceleration. Let me try to get this value. Right, when you press your calculator, you multiply 8 times 9,8 times 0,5 minus 20,37. You divide now by 8. You divide by what? You divide by 8. All this thing you divide by what? By 8. I believe your answer should be 2,5 meters per second. Your acceleration is in meters per second. That's the way I'm trying to get 2.14. I think if we have to explain further to summarize this question. 2.14, they said force F is now removed, then it's been taken out. When this is taken out, it goes down it accelerates downwards. Then the kinetic friction force, we said, is 20,37 Newton. Then we talk of F net. F net is mass times acceleration. F net means how many forces that are acting there is Fg parallel and the friction force we call mass times acceleration. What is my Fg parallel? Is mg sin 30 minus 20,37. It's equal to 8 times acceleration. Then you multiply, you take this and divide, but you ended up having 2,5. That's what I'm trying to explain, guys. I think really this is 2 point. I think I need to go further to another question now. In question 5, let me erase this thing. I think we have got an understanding of what is really happening here. Let me do now question 5. There is a relationship between question 2 and question 5. There is a relationship because in question 2 we're talking about forces. Now in question 5 we talk about the work energy theorem that also involves forces there. Let's go to question 5 of 2017. Question 5, November 2017. November 2017. Question 5, November 2017. Paper 1. Paper 1. Right, here is the scenario. Here is the scenario. Right, here is the scenario. I think now we'll be dealing with change. Here is the block. In the diagram below, 4 kg block lying on the rough horizontal surface connected to 6 kg inexplosive string passing through the furnace pulley. Initially, the blocks held at rest. Very, very important. Initially held at rest. It's very important in physical science. What do you mean by word rest? Rest means your VI is equal to 0. It's very, very important. Whenever you're going to calculate anything, your VI means 0. The question 5.1, what is work energy theorem? It's there in the book. You must, work energy theorem is there. You must take that to marks. I won't go to explain this. This is there in the book. 5.2. When blocks when the blocks are released, 6 kg falls to the vertical surface of 1 kg. You will then, we have got this 60 kg. That is the height. It falls from here to here, and the distance is 1.6 meters. So if it scores 1.6 meters, this also travels again 1.6 meters. It's not written. You must know if this ball moves here, if this move from here to here, this also will move from here to there. One distance will be the same. Right. Draw and label 5.2. Draw and label free body diagram on 6 kg block. Oh, it's two. How many forces here acting on this 6 kg? There are two. There is this tension which is acting upwards. There is this force of gravity. So it's really not a big problem. It's like that. That is a triple diagram. You don't have that is acting on this 6 kg block. There are two. It's just like if you hang something on force of tension. That is tension now. This is the force of what? Force of gravity, right? Let's go to 5.3. I'm trying to be very fast now. Calculate work done by gravitational force on 6 kg. That is very important. What is the work done by gravitational force? It on 6 kg. Right. We don't. It's not a work net. There's a difference. When you talk of a work net, it's a combination of all forces, all the forces that are we talk of a work net, the energy, we talk of a work net, it means you involve a lot of friction force, your force of gravity, whatever the force of flight, right? But now when you talk of work net, what is the work done? It's not a work net. The work done, we know most the work done is F delta X cos theta. I think that's the right. It's F delta X cos theta. That's when you talk of a work done. Right, on 6 kg, this work done, it's not a work net, that's the work done. What is the work done on this 6 kg book? It's not a work net. Work done is F. What is my force? It's F delta X cos. What is this force that is acting? It's force of gravity, which is Fg. Fg, because the force that is acting there is Fg. This force is Fg now. Substituting F, what is the type of F? It's Fg. Then delta X cos theta. Right. What is the force? What is the force of mg? Force of gravity is mg. What is my mass here? It's 6 times. What is my gravity? 9.8. What is my delta X? Times 1.6. Right. The force of gravity now this goes in the direction of a force of gravity, which means my cos is 0 because this blocks goes in the direction of the 6 kg of the force of gravity. So the direction is the same. So my cos is 0. It's not acting against the 6 kg. The tension is acting against. So the tension will exert 180 degrees. The angle that will exert is 180 degrees. The tension, it is the tension. But now it's coming down, which is now the cos is cos 0. Then you calculate, I believe, the answer that you'll be getting. Right. The answer that you'll be getting is 94.8 joules. That's how you calculate the weight. Right, another question. Let's do question 5.4. Could I use the energy principle to calculate the speed of 6 kg block when it falls to 1.6 when it is attached to 4 kg? Actually, we want to calculate the speed. We were told that everything was held at rest, which means, as I told you, my VI is equal to 0. So my VI this thing was initially it was at rest, but now it started to move. It started to fall from a height of 1.6 meters. So if this thing moves this box moves 1,6 meters, obviously this 4 kg will also move at will move at 1,6 watt meters, the same 6 kg. Right? They say use energy principles to calculate the speed of 6 kg block when it falls to 1,6. Right? We know the work net. Normally, a work net is equal to a change in kinetic energy. That's what we know. It's even there at the back of your books. But let's identify what are the forces that are acting on the whole system. We have a force of gravity that try to pull the 4 kg down. Where the friction force that is opposing the 6 kg, which is now acting, that the friction force is always acting in the opposite direction. The friction force by the surface of this table. So my work net involves, that's the work net by the weight. Work done by the weight and the work done by the friction. Work done by the friction is equal to change in kinetic energy. Right. In question 5.3, we were asked to calculate the work done by the gravitational force. I think we did this in the question 5.3. The work done by the gravitational force, where we got something like 98.0 work done by the gravitational force. Okay, let me do it. The work done by the gravitational force is about is mg delta x cos 0. Why I say cos 0? Because it's coming to this direction, plus what is my work done by the friction? Work done by the friction, we are given and we are told that my UK it's 0,4. What is the work done by the friction? Is F delta X cos 180 degrees, which is change in kinetic energy. Friction, 0 degrees in the same direction. Friction is acting in the opposite direction, which is 180 degrees. What is my mass? This is 6 times G, 9,8 delta X times 1,6 cos 0, I believe cos 0 is 1. Cos 0, I believe is 1. Plus, now, what is my friction? We know that a friction force, for the friction force is F UK N, which is, what is my UK is 0,4. What is my N? We know is mg, which is 0,4 times, what is my mass? 4 times g, which is 9,8. Then, which is the friction, kinetic friction times normally 0,4 times mg. Then you multiply 0,4 times the 4 times 9,8. Right. You put it there. You put it here. The friction. You put it my friction. That is, you put it here. 0,4 times 4. Let me try to get the answer. What is the answer? Okay. I don't know the answer. Let me say it's 0,4 times 4 times 9,8. My delta x is the same. If this goes down with 1,6, this should also move at 1,6. That is times 1,6. Then my cos 180 is times -1. This is called to change in kinetic energy. Change in what? In kinetic energy. You multiply the whole thing. 1,6 times -1. You multiply the whole thing. I believe you get 68. I believe you get 68,992 joules, which is equal to change in what? In kinetic energy. That is my work net. Change in kinetic energy. Okay, I write 6,8992 joules, which is cut. Right, let's go to because we are told, we are being asked to calculate the velocity, the final velocity. That is the question. Really, what is my form for change in kinetic energy? We have a change in kinetic energy for 4 kg. We have a change in kinetic energy for 6 kg. So which means I have to say half for 4 kg, it's half times m for 4 kg times Vf squared minus Vi squared. That is my kinetic energy, my change in kinetic energy, this for 4 kg, plus a change in kinetic energy for 6 kg, that is equal to half times 6 times, sorry, let me put bracket, Vf squared plus minus Vi squared. So this is all equal to 68,992 joules. Right, I think we will be having half times 4, because this is Vi is equal to 0, Vi is equal to 0, so this one is equal to 0 times Vf squared plus half 6 times Vf squared. This is also equal to 0, because if this is Vi is equal to 0, here Vi is equal to what? 0. We still need to get the Vf. Yeah, that's how it does. Then you add half of Vf, but I believe you get something like half. They are all the same, times 10 Vf squared, which is equal to 6,8992 joules. What you do, half of 10, I believe is 5, you divide it here. You divide it here, you get Vf squared and then you get the square root. That's what I can do. Grade 12. That's how I do all these things. So you must be very careful to go to look at the whole thing. Then you get your answer. Don't forget to put the square root. Don't forget to put the square root in your answer. You've got 68,9925 half time. Then you don't forget to get the square root. I think we are done in this lesson. Thank you.